and how we have been using that ontology together with other ontologies like the XP ontology. That will be a separate presentation later on that. But also we are using it together with the Arrowhead framework ontology and the CFOS ontology, all under the umbrella of or the upper ontology called IDO, as we heard before. And this is about what we've been doing, how we did it, results, both positive and things that we could have done differently and better, and proposal to the standard organization, what we propose that they should do to meet these demands that are very large and heavy in the industry right now, to be able to use World Wide Web consortia technologies and semantic web to deal with industrial data. And I will also mention a little bit about what we are planning to do further with this technology that we have developed. So let's start. Context and objectives. What is the takeaway from my presentation? If you remember something, remember that what we've been doing to create this step ontology has been feasible and very, very positive experience. And what we've been doing is that we have been from the beginning do it the manual way, and then we did a second round, and we have done it now in an automatic way, and we can still preserve engineering semantics and handle complex data types and other things that exist in STEP, and without losing it when we create an ontology out of it. And we've been using industrial data ontology to connect the STEP ontology with other ontologies using alignment. So we have not just one large knowledge graph. We have 1, 2, 3, 4, 5 different knowledge graphs that play together to resolve the requirements from the business processes. So overall, it's been a very pleasant work to do this, even though the first part doing this manually was a little bit cumbersome and work intense experience to do, but now it's been in the end rather positive. One of the things that's made this possible is the fact that what we've been using is the STEP standard, and the committee starting that work was started in 1984. So it's more than 40 years ago. And at that time, there were no modeling languages. So they came up with their own modeling language called Express. And there were no architectures when it came to standards and so on. And all this has been developed and redeveloped again inside that committee. What we've been starting from is something called the new architecture of STEP, and it's based on a way of using SysML v1 for information modeling, and the fact that it's an UML standard. We can also generate XMI for modeling interchange. And that's been very, very fundamental for us when we should translate transform these models to ontologies. That work was already done. It's been industrial proven and is in use in many places in the industry, or some of the standards in STEP is used every day, a million of transactions. STEP is a large standard, depending on how you count on things, but it's over 800 standard numbers. Some of them are just resources, but let's say there are like 30, 40 major standards coming out of this technology stack that's been developed by this committee. This committee also developed standards like ISO 15926, which is a well-known reference data or the reference data library of the world. And it's also connected very much to my friends at Post-CSAR Association. And without this knowledge in the PSA, this work has also been very hard to do. SF4 drives billions of dollars in economic benefits and is one of the real good examples of information model standards. The interesting thing is that there is a move inside SF4 going in the direction of ontology and ontology-based interoperability, digital twin, data-driven compliance, and so on to fulfill their Industry 4.0 innovations. So it's still a major standard committee in ISO with good cooperation with IEC, the electrical standards, so they are getting more and more together. There are different kind of models in STEP. There are these major ones. The top one, AP242, is, if you think about what's that about, I should say it's about CAD a little bit. Not 100% correct, but it's mainly about exchange of 3D models between all the major CAD tools are supporting this and utilizing this all the time. In the bottom, we have the other one, which is the PLM standard, AP2 through 9, called Product Lifecycle Support. And the combination of these two is supporting a lot of the engineering work in the business processes inside engineering. But there are other standards also, and many of them, like 25 perhaps, that are more specialized. One of them is this, what I put there, AP209, which is about analysis and the design, and CIE, finite element, and so on. And they are always interconnected with the other standards, the AP242, AP2 through 9. There is one other major one called AP2 through 8, which is about manufacturing. But good thing for us when we were now moving this into semantic technology is that they already are very integrated, these different things. What we have done is that we have started with the overlap, the scope overlap between AP242 and AP2 through 9, which cover a large portion of the STEP standards, and the SysML model of these of the overlap. And that was a real good start to start with, and I will come back a little bit more about that later. So SysML core model, that was I talked about, the overlap between AP242 and AP2 through 9. And we were using the export advantages, XMI, and it's the SysML is done using Magic Row, is called something else nowadays when it's on Dassault product, but so the XMI is generated automatically from the SysML models. And it generates this rule-driven ontology mapping. Mappings interpret model constructs into OWL to DL classes and axioms supporting consistent semantic integration. There were a few things that we needed to change a little bit in the mapping. It exists on step standard how to go from XMI to XML schema, and we used that as a starting point, and we tweaked it a little bit. So instead of doing XSD, it's created OWL to DL, and that was successful. So the architecture that we've been using for this validation is that we have an upper ontology, the IDO, and without IDO, a lot of these things would have been very hard, especially if we should come up with our own upper ontology. But that's an OWL to DL ontology. It provides shared concepts such as asset, equipment, process, function capabilities, and so on. And we used this other level, domain ontologies. We used step core ontology, and that's what we've been, I will talk about today. It's a rather large model, and but we were able to generate the ontology automatically, and I will come back to that also. But one important thing is that what we've been using is the DXP ontology to define the system. You know, the system describes how it delivers the functionality to the system above. And this is about the system of system, and that this is process instrument diagrams, and that's standardized in the DXP ontology coming from DXP organization. The third thing on the next level is this Arrowhead framework ontology, and Arrowhead is the EU project that we've been working with. It's about federated systems and based on microservices. And what has been done at the Luleå Technical University, that they created an ontology out of this cyber-physical system. So we have very stable things to the two others. They are rather stable when it comes to information, while the Arrowhead framework ontology is about very dynamic data, sensor readings, and so on. Of course, we like to try this also. So we got instance data. So we created knowledge graph, one DXP on knowledge graph, one step core, or in some cases, two step core, one for the product and one for the plant, and one Arrowhead knowledge graph. We are also working with something called CFOS, which is about classes and allowable properties of these classes. And what we've been using is that we have aligned these ontologies to a few of the classes in DXP, step core, and the Arrowhead are aligned using the upper ontology. We have also integrated 3D viewing on using the Semantic tool, where we have a 3D view of this instance data. So we can click on something in 3D and get immediately into the instance data. We have concentrating using GraphDB from GraphWise, and that also been very, very good and solved a lot of issues for us. But we are also interfacing with SAP, and we have created a SAP HANA API following the SAP HANA API definition. So we can go from Sparkle to SAP HANA API, and we can get data back and forth. So this is the technology stack that we've been using to validate the idea about the step core ontology, but also in combination with the XP ontology and the Arrowhead framework ontology and other ontologies. As I said, we've been using in number one there, we have used cross-standard alignment, and that's one of the reasons why we are doing this. You know, there are many standards, and most of them are stovepipe standards, and some have tried to build one technology stack and one modeling methodology to create one standard for everything, but we believe that we need instead to work with interoperability between different standards, and what we have done now is proving that works very well. Another thing that made this possible was that we had a good relation with this ISO committee, and both on personal level and also on organizational level. So this EU project is a liaison to the STEP committee or the ISO TC 184 SC4 meeting, but we had also many personal relations with people, experts that invested their working life into this kind of modeling and so on, and it's been really useful to know them, and they have helped us a lot. What we are also, we have from the beginning, we have been very careful to do this in a controlled manner, so with governance and automation and so on, and that's been also a very good input for this. Why are we doing this? Yes, you could say that some of us do it because we believed in standards so much that we wanted to get it working. And this has been the most successful thing. I've been involved in these standards for 35 years, and I wanted to see it working sometime. And this is working, and that's a fantastic thing. But we can say also we reduce risk. We accelerate onboarding, since we are using these alignments. We can easily and fast add new sets of information in different other knowledge graphs, just by like adding a link to another knowledge graph. Then you have another universe available to traverse to find out things and solve issues. And the way we've done this is using the technologies of V3C. We were very happy with the choice of GraphWise, since they were heavily supporting the technologies of V3C, and it's been successful. Methodology and the proof of concept. So from the beginning, we had an idea that we should use this XMI, and we have the idea to do it by parsing XMI structures and creating our 2DL ontology. I talked about that before. It's machine interpretable semantics, support automated reasoning, and it's make the maintenance evolution easier. And mapping and semantic handling, we were using, of course, SysML classes was OWL classes, associations were OWL properties, but on a more detailed level, we have to do some small changes. We of course use the constructs that's available in OWL, like generalization and so on, and we had to solve the issue that there is one thing in STEP called select types that's not really a specialization, it's more a union of, and saying if you have these classes, you could also connect them to this kind of model construct, and it fits very well. So we used union of in that case. We are not really sure that this is the best way, but until now it's been working very well. Me and some others did manual translation from the beginning, and it took some time. But we learned a lot about both OWL as well as XMI and these things. And last summer, we were in the situation that we could create an automatic translator, taking the SysML XMI and generate the AL2D ontology outputs. One benefit that I said was the way that step core is created. It consists of like 45 modules, and this is the Magic Draw SysML V1 or one of these modules. And when we did this manually, we took one module after another and we created a translation for each class and concatenated them. And in the end, we have done like 14 modules, and it worked very well. And we were surprised, more or less, that it worked. And we were able to create a knowledge graph based on that ontology. One of the things that we have learned now is that it's very good to have this modularization. What we did when we automated this was to generate one large ontology, and it's better to have it this way, we believe. And that's one of the things that we recommend to do in the future. And we have used IDO as harmonizing ontology. IDO enables efficient cross-standard queries across STEP, DXP, and Arrowhead frameworks by linking related data nodes. And the way we do it now, that we import data into GraphWise, and then we use Sparkle to do the cross queries. So we are using the endpoint technology of V3C. This makes the integration complexity and the interoperability creation much easier and easier to understand. And it also simplifies governance and onboarding, as I said before. We have just done very lightweight alignments. In the DXP ontology, we have something called tags, and the tag is also represented in the step as a function, the step ontology, and then in the step there is also parts or part models, and we have equipment which are physical things, and the physical thing is mapped to Arrowhead physical equipment or components, as well as to CFOS equipment. So there is like not so much more than 10 different classes that we have aligned. Still, we are covering the full life cycle of a plant or what it is, and that's rather impressive. So we have just done this. If you see in the bottom, we have done minimal alignments to fulfill going from function to equipment delivering the functionality needed to support the business processes on a high level. But we believe that we can expand the alignments to get better support over time. And for a long time, these are stable standards. So we could have a very good alignment in the end. But right now, with the minimal thing that we have done, it is still very valuable. And we can do things with this interoperable knowledge graphs that's you can't do it in any other tool, more or less. I mean, you could do parts of it in SAP, you could do parts of it in Aveva and things like that, but not everything that we can do right now. One thing that's really cool, I like to say, is that we have this Arrowhead framework ontology, where we have the living data of the sensor readings in the cyber-physical system available together with the step core ontology, the DXP ontology, all aligned through the IDO upper ontology. So we can do knowledge-driven service discovery, which is really, really interesting. We can check sensor readings of a sensor. We could figure out, okay, the sensor is located there, but what is it really measuring? And we can do assessments of what to do and so on. That makes it possible to do operational decision support. Decision support is what's really needed. And right now, when we are working with the end-to-end demonstrator of use case 2.9, we are discussing how to do this and how to automatically generate work orders or open work orders, and how to use the knowledge in the knowledge graphs to evaluate what should be done. And we also then create the work order, send it to the SAP, and we carry out the work order, and we update the knowledge graph so we know what's happened. At that time, we replace this pump with that pump, with the serial numbers and so on. Still, they are supporting the same tag. We can also do redesigns, but then you're into changing the DXP system also. So this is, I don't think that we have understood what this Arrowhead framework ontology will mean in the future to support real systems in real life. So things that we are now going to demonstrate, and we are now going to create a large set of small videos to demonstrate what can be done. One of them is linking design to equipment. If you have this PNID and we have a PNID tag and we can keep track of that PNID tag is a part of is resolved by a theoretically resolved by a part, a pump type, but it's also resolved in practice by an equipment instance. And we can follow the history of this. If you have a 35-year-old plant, we could keep track of all changes and all rebuilds and everything in this knowledge graph, and that really gives us a good foundation to understand what's going on in the plant. We can also do configuration and documentation evaluation. We can look for maintenance procedures. In STEP, they are not documents. They are work instruction and procedures. We can do simulations in cooperation with the company Semantic and finish VTT and so on, we can do simulation and keep that the simulated behavior close to the step core, so we can have that at hand when something happens. And of course, there are still documents available, manuals, data sheets, and so on. We can do this runtime integration that I talked about. We have the Arrowhead services and the Arrowhead microservices, and that is one key enabler for what we could do in the next step. We have not evaluated or taken advantage of it all yet. The strength is that we have a very clear domain-specific meaning of assets and their relationships, stable links between the XP, step core, and Arrowhead with minimal couplings, actionable runtime operation. We can make actions, and that's what we are going to demonstrate coming month, where we have this sensor readings, sensors located at a specific place, and generating a work order on this. And it's really scalable. We have not reached any problems with performance at all right now. So the main demo that we will do is this end-to-end flow overview thing. We are going to do PNID and tags with the equipment instances, configuration and docs, and Arrowhead services, generating problems, signals outside the threshold, and so on, evaluating what can be wrong, create a work order. The work order will be executed, and we will update the knowledge graphs and have that historical data from that time that the new equipment is running. We have also been thinking about what should we recommend TC184 SC4 to do, and we believe that all the standards that are fundamental in SC4 should go in this direction, and define the mappings or the transformation, I like to say, between SysML, UML to our 2DL. Perhaps we'll find that there are still semantic gaps in the XMI serialization, or that there are transformation problems, but until now we have not found any. It is a little bit non-humble, but that I have to say that. Sorry. Established canonical RDF owl representation alongside XMI. That's one of the things that we recommend ISO to do, to establish a standard owl RDF format or technology or standard alongside the SysML one and the XMI representation, and so right now it's something that is a result of a GU project. It needs to be an ISO standard. This all these need to be tested in pilot projects to check the semantic translation. We also have some KPIs, but we don't have to spend too much time on that. Later, we need to have a good pipeline for this, from XMI to RDF owl to DL transformation pipeline. We spent a lot of time to understand how they did this using this document, defining how they did XSD from XMI. If there been an automated open pipeline for this, we should be able to do this much faster. So that's one thing, that we need to leave the document paradigm in the standardization in ISO and go for these pipelines, open pipelines. We have not done that so much. We have done much more Sparkle things than Shackle. We have done some Shackle work, but we believe that should be a part of such a pipeline. So Shackle and Sparkle and the other technologies are really one package. And that's one of the fantastic things that we discovered, that if you go for this, you can do whatever you would like to do when it comes to standard and knowledge graphs. Still, they play together. Later, we hope that they will be ISO technical specifications like SysML models in R2DL or constraint validation using Shackle and so on, and also how we can get this to work seamlessly with these reference data libraries like ISO 15926-4 and CFOS. Key message: XMI is a syntax, not a semantic layer. By standardizing on all 2D representation of SysML models, we enable machine understandable, interoperable engineering data across the digital thread. And strategic positioning: standardize a semantic representation of SysML models in our 2D to complement XMI, enabling interoperable, machine understandable engineering data across the digital thread. This is what we believe that we have at least proven to 80-90% validity, that this is possible, is useful, and should be done. When it comes to implementation, we are been working with Stora Enso, which is a major paper mill company in Finland and Sweden. And the proposal is to go on with this. We like to work more with 242, which is also about 3D data. And we will need to have a governance and quality control cadence. So you know that this is working over time, and set up a convincing and understandable demo environment for such a large organization. We hope that this is going to be used also in other places, but right now we are thinking about how this should be done to make it possible to this large industry that still are on document level, even though they have created PDFs out of their process and instrument diagrams, but they are still documents. But there are things that we've been working together with a company called Semantic. They have tools to take these PDFs, PNIDs, and generate knowledge graphs. But we will come back to that when we talk about DXP. DXP is as important as STEP when it comes to fulfill end-to-end life cycle management of large assets like paper mills or oil machinery and so on. So this is a good step forward. Yes, that's what was my presentation. Are there any comments or complaints or questions?
I can see at least one hand raised, so go ahead.
I think it was Vladimir.
Yeah.
Yes, and I will first join into the clapping. A very impressive presentation. Congratulations on all of the work you have accomplished. And we're really honored that you're using GraphDB for this kind of stuff. Did you get support from GraphWise or it just works?
I should tell you that we have been working with persons who has been worked a lot with the GraphDB before. A person called Lars Wikström, and he helped us a lot with this.
Triona.
You probably
Okay,
could understand that I couldn't figure this all out myself, so he's been very much supporting us. And GraphDB has been really stable, and it's. I mean, I should say we have not been using